making a draft physics video. Comments. And something probably about light bending, but the subject really isn't bending. It's just the fact that light changes its direction when it travels through some substances, namely transparent ones. But anyway, we'll get to that eventually. So the jack and apes, I don't know exactly what that means, but whatever. I'm not sure it's accurate to refer to Susskind as a fake physicist. Well, it wasn't called fake physicist of the week, it's physicser. But, clearly my argument isn't that everything Susskind says is wrong or stupid. I was making specific arguments about a specific part of his theory. Now, I'd say most of his theories are stupid, and that can be demonstrated if you just watch this latest Sean Carroll's Mindscape. So if you watch, with Susskind on quantum, so that's episode 45, type that in to the search and you should get it, Leonard Susskind on quantum. And it's just a pile of crap. I mean, it was all on black holes and multi-dimensions and I don't know, it wasn't even entanglement, but it sort of was. And then qubits, of all stupid things to talk about. But there was nothing that had anything to do with any real science. It's all just made up crap. And it's just that. It's made up crap. I mean, they're just drawing a cartoon that fits a couple of little features that exist in the universe. But you could draw all kinds of different cartoons based on the shallow view of reality they're taking. I mean, so much of this is so related. I mean, because the conversation about light sort of gets into this in terms of light interacting with surfaces. And they pay absolutely no attention to the fact that surfaces have a character. So every conversation is always just about what the photon's doing, and none of the conversation is about what is the photon transmitting through. What the hell is it hitting? Not just don't pay any attention to that. Like the surface doesn't matter, and like the surface has no structure. And Susskind does this all the time with this theoretical physics in terms of let's just forget about recognizing all the conditions you have to meet, and let's only meet these two conditions. It's just horrible physics. But anyway, are you basically saying that what we see as a randomness, again, we don't see randomness, we see a probability. We see that it's 3 degrees or 6 degrees or 12 degrees or 15 degrees. And you're assuming that somehow that's happening randomly, and I'm clearly stating, no, it's happening because the photon hits something in a different condition, and depending on the condition, it changes the angle. So if it hits one electron, it goes 3 degrees. If it hits 2 electrons, it goes 6 degrees or 0 degrees. If it hits 3 electrons, it goes 9 degrees or 6 degrees, depending on which way it went, left or right. So I'm just saying that, you're the one assuming that it's random when there's nothing about it that says to you it has to be some sort of random event, just like the clock goes to 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. Again, you could say if I choose moments during the day based on when bluebirds land on the fence and I look at the clock, because there's no connection between those two events, it'll appear random. You end up with the clock there won't be any specific time, but it's not being caused by anything random. Anyway, in quantum mechanics, there's only a limitation of our capacity to measure and process the information. Well, processing it isn't a problem. Measuring it is the big problem. Yes, that's always been the issue. We can't measure photons. Can't see them very well. Can't detect them at all in a passive way. So you can only measure them based on their destruction. That is, you can only know them. It's like only knowing a meteor based on how it lands on the Earth. So you have to make deductions, because you can't see it in space. You can only see it when it lands. And some meteors coming at different angles might look like, the same kind of impact, and you have to kind of analyze it carefully, or you could be fooled into thinking it was bigger and it was moving slower, or you could think it was small and it was moving fast. You could draw all kinds of wrong conclusions. If so this is the funny part. Are you basically, yes, I'm saying there is no goofy action at a distance. There's no spooky action. There's no silly action. Everything happens for reasons. The causes are mechanical, and they have to do with how photons and the condition of the electron the photon hits. If the condition of an electron is a certain condition, the photon will do one thing. If the condition is a different condition, then the photon does something else. That's what's determining the outcome. There's nothing magical in any of it. That's my assertion. Yes. There's no... The whole idea that there is some weird, wacky dimension or weird, wacky function of photons. Photons are the simplest thing in the universe. They only do two things. They have a certain amount of mass, and they have a velocity in a direction, one direction. And that's all they got. They got nothing else. No magic tricks. If so, I'm pretty sure, well, of course there's a frequency, sorry. I mean, obviously they're quanta at a frequency, so there can be a ray length also. If so, I'm pretty sure that's true. So again, I don't know what that means. So you're saying, if I answer the question, yes, that's what I'm saying, and you're saying, I'm pretty sure that's true. So you're saying you believe that the limitation is in our measurement, not in the fact that the universe is too wacky for us to see. Isn't this kind of what chaos theory is all about? I don't think chaos theory makes any sense at all. It's just smashing two stupid words together and saying, there, I've said something. The fact that the universe is complex, there's a lot of pieces in it. This bottle contains, gazillions of elements. Particles, you could call them. Gazillions, trazillions, bazillions. Many, many billions of billions. In this one little bottle. There's no chaos going on in there. There's just our problem of not being able to model something with so many pieces. That's it. So there's no chaos theory. There's give up theory. There's holy shit, there's too much shit theory. But that doesn't mean anything as a theory. It's not a theory about how anything works. You're just conceding there's lots of parts. I can't follow them all. Therefore, there could be a couple that are doing something stupid. And so 99% of them could be doing something very regular. And all you need is 1% of them do something irregular. Just like the poison apple ruins the pie. One bad apple. I mean, so what? That's not a theory. That's barely a fact. Modeling and heuristics, because we can't model with absolute accuracy. And again, who had the assumption that we could? Who in human history was dumb enough to think we could possibly model gazillion, I mean, I don't even know how to describe the size, the magnitude, the amount of stuff involved in producing the universe. I mean, it's an insane amount of stuff. And to sit there and think that you have a model that could track every little bit and make sure you have the accurate history of every little bit would be fucktarded. But that's not a theory of anything. That doesn't describe you're not describing how it works by saying, gee, there's a lot of it. That's not a theory. Fuck. Anyway. Alright, so our Brovoy. Okay. So he posted a link this time. This is the Fermi lab I was referring to. If you don't find it interesting at all, sorry for wasting your time. Well, what am I supposed to say? Yeah, I'm sorry. I don't find it good physics. So here he is. So he does debunk a couple of wacky wave theories, which is good. And especially Huygens, he takes a shot at, which is fine. All theories about why light diffracts. But the one he chooses to say, this is the right answer, he doesn't provide any mechanism or any insight at all. He just shows Maxwell's equations and says somehow Maxwell's equation solves the problem, when Maxwell's equations don't give you a why answer either. They're just a description of an outcome. We already know what the outcome is. So again, there's nothing miraculous in that. And the fact that you can proportionally relate two variables, just like the fact is you can pretend that frequency ends up being a representation of something's intensity, by logic, by saying that things that happen, a lot of things happening in a short period of time, it has more intensity than the same number of things happening over a long period of time. And that's sort of a valid thing to say, that it has more energy. So then you can say, okay, I'm going to use frequency as a substitute for momentum, because it affects momentum in certain circumstances. And so, you could say, okay, so then it ends up being valid to say that something like an electron or a Volkswagen traveling 40 miles an hour has a frequency, when we know it doesn't have a frequency. But for a mathematical purpose, we could say it does, because it's kind of interchangeable because of the one circumstance in which we made it valid to associate frequency with momentum. But it's really not. It's not true in any sense. And so the same argument could be made that the Fermilab explanation is just, he's again, it's just this stupid, measuring the electric field and saying that, well, we already know that this permittivity number changes for the glass, so the constant changes, and it changes by this certain amount, and that amount's proportional to what we can say the electric field changes by. And so they're just doing the same thing. They're just creating a fake component to sit there and now replace the constant with, to sit there and create the change with. But that's all they've done. They haven't, it's all fake. There's nothing, none of it represents any kind of real property. Now, we already know that the light bends on the surface. That's a fact. And it bends coming out of the surface. Again, that's a fact. It travels a straight line through the material, functionally, at an angle from the surface. So this isn't something that can be any interaction that takes place atom to atom. It obviously only happens on the surface atoms, and only happens on the surface atoms when it's leaving. So it's only the surface atoms that are causing the effect. So your explanation has to have something to do with the character of the surface. And they don't say anything about the surface of the glass, where clearly it's a surface phenomenon. I don't know. Going through this over and over again, not much point. All right. No need for name calling and such. I don't know. Did I call you a name? My point is you gave a vague reference, and I find that irritating. And then you don't say much in the, to explain what the link is to. So you called it light bending, but clearly that could be meaning gravitational lensing type bending. That's the better term for bending, right? Bending is turning something in kind of a slow way. You don't think of bends as being sharp angles, right? Bends are when you bend a pipe or something and it's round. Bends aren't, it goes at a precise angle. So, this is part of the language problem in physics. They use all these words, and they're really not very descriptive. And shouldn't that be what science tries to do, is get to very explicit and descriptive definitions, not ambiguous ones. And to say light bends when it goes through glass is kind of, when clearly it's more like a reflection than is a bending, right? Nobody calls reflections bending light. but it's clearly very angular and very precise, just like a reflection. That's why they call it refraction. It's not bending. So, the subject of the video was light refraction. The subject of the video wasn't bending light. All right, anyway. Maybe I'll play some of it just for the hell of it. Maybe I'll play some of the Susskind thing, just clips, just little pieces of it, just so you could see how obtuse the whole conversation was, so abstract and so disconnected from anything that could be called real physics. Just unprovable nonsense. They have this, I didn't realize they had a theory that black holes disappear, which doesn't make any sense in my opinion. And they just leave behind Hawking radiation. Well, what the hell is Hawking radiation anyway? Can we detect it with something? I mean, it's just so silly. Anyway. All right, the acorn. I watched it. Pretty good explanation. I think it's a pretty poor explanation. The only thing valuable about it is the point where they say something about the fact that the actual path the light takes with the bend is equal to the speed difference. Would be the shortest path considering the shortness of the speed difference. So because there is a technical thing about going slower, so there's a way of maximizing the line where you're taking the shortest distance. But I mean, that's assuming you have to do the bend in the first place. So again, that's part of the illogic of this conversation. Is it's only the shortest path if you assume glass is molasses. And it's not. The light takes longer because the light's not traveling freely through the glass. The photons are communicating between the electrons. They're like electricity. There are pressure between electrons. And that's how they get from one surface of the glass to the other surface of the glass. They're not really photons in a sense, okay? They're pressure. And they transfer the pressure from electron to electron to electron to electron, just like electricity. And there's a certain time it takes because the electrons are doing the moving for part of the movement. So part of the movement is at the speed of light, and then part of the movement is at the speed of the electrons, which is much slower. Anyway, pretty good explanation. Much better than Up in Atoms. I don't know who that is, but that's a silly girl, right? Sorry, girls. But some of you are silly. It's just true. That being said, all these path videos for light into different mediums focus on a singular ray of light. Well, no, they really don't too often. I mean, most of the diagrams have a whole bunch of rays going in, and then they try to make it into something that turns, like a whole line of soldiers turning, when we know these are individual photons that bend. A single photon does everything a group of photons does. So it's just bullshit to draw it as a bunch of lines coming in, because a bunch of lines coming in isn't how the photon works. The photon isn't a bunch of lines coming in. A single photon is one line coming in. You can't use some nonsense that the whole row turns. Alright, when we know there is almost uncountable rays of light on Earth. So again, that's just irrelevant, because the really important thing to know is that single photons bend, are deflected, are refracted by the substance. And in the experiment in the above video you linked, we could say there are at least 1 million hitting the target in question. So again, I don't know why you think that's... I mean, you're seeing it exactly the opposite as I'm seeing it, which seems weird. Why do you think it matters if there's a group of photons or just one photon? We know that the reflective index of the light doesn't change based on how many photons are hitting. The assumption comes in that light always takes the shortest path. Well, the assumption that there's a path that light is taking when the light isn't making the path, the substance is making the path. So, there's a hiss in the computer. What the hell is that? Stupid freaking headphone jacks. Anyway, always takes the shortest path. Well, it's not an assumption, that's sort of the fact. So again, it just happens to take the shortest path if you consider the medium as being molasses. Something much slower than running on the beach versus swimming in the water. So you swim much slower than you can run on the beach. It's a perfectly valid analogy, but it's just a byproduct. That's incidental. That fact isn't the elemental fact. That isn't the fact that's causing the effect. That's a byproduct of the effect. All right, anyway. In all of Fermi-Lab quantum videos, the assumption only holds true if you are focused on a particular ray, set of rays, or photon. I mean, that doesn't even make sense. So set of rays would be different than a single ray. So how can you contrast? Now you're including everything. You've just included everything there. Ray and set of rays or photon. You're basically saying a single photon or a set of rays. It holds true for all of them. So why are you saying only? It only holds true if you include everything. You included everything and said only holds true. Sorry, this is this is nice that you wrote all this stuff, and I'm picking to I didn't intend to do a. I mean, I'm the last person to do grammar lessons, but frankly, it just doesn't make any sense. Light moves in straight lines. Great, thank you. Until it strikes something that can be absorbed, reflected by. Great, fantastic. That's there. That's a fact. And anyone who disagrees with that fact, I think, is the one we should be suspect of. All right. Its angle of reflection is based on Snell's law. So again, another, I'd say, stupid thing to say. Obviously, Snell's law is just a reflection of what it does. So Snell's law is a byproduct. It didn't cause the effect. It's just an explanation of what we already know that happens. So Snell's law isn't a law of physics. It's merely a description of a fact. I mean, damn. However, what we see these YouTube physics content creators doing is looking for the particular ray of light that has the shortest distance to a particular reference object in a different medium, and then claiming post hoc that light always takes the shortest path based on viewing that specific phenomenon. Well, clearly the light's not taking the shortest path, or it goes straight through the medium. So again, it's only the shortest path in the context of recognizing that the light will be delayed in processing through the glass. So I don't know how to say that. But again, that's just a byproduct. That's just a symptom of the fact that it does have to go through the glass, and it does take time. One isn't causing the other. Well, I'm just saying the causes are reversed from what people are thinking, I think. All right, anyway. Where was I? Per particular ray, blah, 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 always takes it based on viewing that specific phenomenon. That's even wooier than the quantum stuff that they tend to throw around these days. Yet that and other false aphorisms tend to seep their way into modern quantum theory all the time. Well, modern quantum theory is just absolute made-up crap. I mean, all of this stuff based on, the crappiest evidence. The experiments are insanely complex, full of assumptions. They can't be trusted to draw conclusions. I'm wondering if part of it is just a lack of qualifications. Many of these people have only 4 years physics degrees and no degree at all. Educated from online content creators of similar statutes for the many years. I don't know what that meant. Statures for many years. I don't know. I'm guessing a large proportion of them grew up watching Michio Kaku and Neil deGrasse, who avoid quantum explanations like the plague in favor of layman interpretations and explanations to the lay public. I don't even know if that's true. I mean, Kaku is a string theorist. Degrassi Tyson is just a clown, so yeah, everything he talks about is put in kind of simpler jargon. He doesn't seem to be an expert on anything. A huge problem I see with the approach of quantum is not like classical physics. So this whole, again, like somehow there's the theory of evolution, and then there's some new theory that's supposed to be the real theory. The classical observations are still valid observations, so let's be honest about that. And most of the fundamental principles are solid because they didn't jump the evidence. I mean, Newton wasn't allowed to jump the evidence because, back then scientists had to have some sort of integrity. And being wrong was a really bad thing to do, so they avoided being wrong. And they don't avoid being wrong now because there's no one to catch them, I guess. It's not easy as analogized. Well, I think it's even simpler than analogized, and that's the funny part of this whole conversation. They have made these stupid assumptions that everything's much more complicated than it really is. It's just about force and matter. The force has all the motion. The matter inherits whatever motion it has by absorbing force. I mean, it's really that dirt simple. All right. Analogizing often skips several key factors you need to know about their theory, including how to counter alternative theories or contradictions you may find in their theory. Well, that's sort of exposed in the video in the sense that, Huygens has some traps that nobody bothers with because, yeah, they just care about the part that works. But the truth is if you play it out and you look at it for its real consequences, just like you start looking at the slit experiments and recognizing that, yeah, well, the single slit doesn't work. Light does something fundamentally different than what water waves do. And then the multi-slit is, yeah, fundamentally different. You start to realize this isn't a solid analogy. There is so much material in quantum that you can basically paraphrase a Wikipedia article after reading on a specific topic and put it in your own justifications for it without truly grasping the concept. Well, I don't think there are concepts in a lot of this crap. It's like saying there's a concept to dark matter, besides the fact that they desperately sought a solution to a fact that one of their mathematical formulas didn't work. And they had to find out they couldn't accept that their formula could be wrong or that their assumptions were wrong, and instead they decided to change the universe by creating crap that doesn't exist. I'm guessing a lot of it just a reinforced echo chamber because of the facts I just mentioned. Well, the big fact is that nobody can challenge these people because they veiled and covered everything in this mathematical jargon, and they've done everything they can to keep all that mysterious and inaccessible. So they hide it behind symbols. They don't just say what it is. This is the angle, this is the distance. Instead, they hide it behind lambdas and thetas and deltas and all kinds of other crap, to obscure the simplicity of what they're really doing, which is just saying, the distance from point A to point B is proportional to the distance between D and E, and it's the inverse of, inversely proportional to how wide it is, what Z and X is. Some kind of simple thing like that, and they make it sound like it's all complicated, when it isn't complicated. I totally agree with your criticisms, DraftScience, that quantum theory is lacking reliable, understandable mechanisms. Yeah, well, they don't have energy. They don't have a theory, a model, in the sense that they, have lost sight of the fact that they have to be able to do this trace it thing. And they're not tracing where the energy came from. They're just calling it something stupid like bent space or a virtual photon. And as soon as they said bent space or virtual photon, somebody should have raised their hand and said, no, there's got to be a force. The stuff moves, there's a force, right? So that's the difference between classical thinking and modern thinking. the classical thinkers had to account for how it's happening. Newton knew there had to be a reason. He said, you'd have to be an imbecile to believe it just happens, right? So he was basically saying, nobody falls for that. But I can't tell you why it's happening. We know there's got to be something that's making it happen, but I don't know what it is. But he wasn't stupid enough to think, oh yeah, it really is spooky action. That quantum theory is lacking reliable understanding mechanisms. Their before and after explanation in regard to cause basically begins and ends with the Big Bang. Well, I wouldn't even bother with that one. I mean, the fascination with attempting to describe something so distant from the current evidence, right? I mean, the evidence we have is so distant from that abiogenesis. I mean, it's one thing to speculate about how the chemistry of life got formed, because that's realistically within our grasp. To attempt to pick up the pieces of evidence and take them backwards, and we could draw a picture of that and come up with something that might be close. But to do it to the universe is just, I think, just a silly pursuit. I mean, you're just not going to, I don't think you're going to find enough evidence for the conclusions they're drawing. And again, they've decided that this redshift thing means there's new space being injected into the universe all the time, which I just think is ludicrous. I think this guy is going to claim that as a realistic explanation of something. I think that happened somewhere in this comment. Sorry, they are claiming bent space is causing light to bend, when most advanced physicists will tell you that it is space expansion. So there it is right there. What the hell is that? A space expansion. Man, how can that possibly work? I mean, frankly, if space is expanding, it has to be expanding inside atoms. It has to be expanding everywhere. So why wouldn't it break neutrons? And neutrons are composite particles. And why wouldn't it be having catastrophic effects, because all the charges wouldn't be balanced anymore? I mean, it doesn't make any sense. When most advanced, is causing it. And again, space expansion only happens around gravitational bodies. I mean, is that your theory? Space expands more where there's more gravity? I mean, it just doesn't make any sense to me. How or why they want to reconcile those two contradictions is beyond me. Well, I don't know why you're suggesting space expansion is better than gravitational bending, because both of them are nonsensical in my opinion, and certainly are not well evidenced. The latter explanation makes much more sense and doesn't have to violate known laws of physics. Well, you should have cited what known law of physics bent space violates, because frankly I'd say expanding space violates more laws than bent space. For those still in favor of bent space, just got a video from 60 Symbols, and they themselves admit that space expansion is causing light to bend. So we have another reference to a video, so I don't know, I didn't see that one. But I'm calling bullshit without any reference to the ridiculous Einstein infinite well model. Well, you have to have a reference to gravity, so I don't know if they're not claiming that light is being bent by gravity, then you have to explain why there's more expansion near heavy objects, because apparently that's where most of the lensing is. Now, I would argue there's no lensing, so it's not an issue, but I'm just saying their assumed evidence is consistent with some notion that there's gravity in the places that are bending light. Or any reference to the idea that gravity can bend the trajectory of light. So, and again, let's understand what gravity is. Gravity isn't the presence of force in a sense. It's the absence of it. It's creating an imbalance in force that is preventing force from getting to something. except in the case of black holes. You know, well, another unproven thing. When it comes down to it, though, there is a priest class, but the priest class is so involved in cutting-edge research and technology that they don't care too much whether the information they or their followers disseminate is truly accurate. Now, I don't even know how involved they are. I mean, they're involved in just childish expansion of imagination. I mean, they're just saying, well, how many heads can I put on Tinkerbell? You know, how big can I make her boobs? I mean, they're just making this shit up. Their honesty, to me, seems like they are pushing the woo until it returns to them, us, with a great invention or violates classical physics. Well, I'd argue they can't demonstrate they've ever done either one of those things. That computers couldn't have been invented, okay, without quantum mechanics, because I think they could. I think once they understood the principle, it was just a matter of trial and error. The problem with that approach is, since we are contained in the classical world as humans, well, whatever. I don't think there's any other world but the classical world. So, God, this mouse thing, I don't know what it is. I don't know whether something's interfering with the microwave signal, what it is, you know, the wireless signal. Anyway, theories and inventions involving violations of it may essentially be a bridge to nowhere in most cases. Theories and inventions involving violations of it may essentially class world as humans. Theories and inventions involving violations of it. I don't know what it's talking about, what's violating what. But anyway, they are fun to think about. You can do advanced calculus with them, and they give you an idea of what the future could look like 100 or 1,000 years from now. I don't think they do any of that stuff. I think it's all a bunch of fakery, wormholes and all this nonsense. There's never going to be one. None of that crap's ever going to happen. No one's ever going to pop out of a black hole. It's all crap. But I think they need a dose of realism, classical physics, if we want the field to be applicable and efficient again. I don't think there's any efficiencies to glean. I don't think there is any. They're not going to make a quantum rocket. You know, they're not going to make a quantum screwdriver. Classical friction and mathematics are classical fiction and mathematics are in many ways harder, and some of the summarized theories of quantum because of the diagrams needed and the forces involved. Alright, so somehow quantum's harder to diagram. Well, yeah, but it's also nonsense. I'm sorry you think it has any value. I mean, the only valuable word is the word quantum, and the word mechanics. That's a good word too. Okay, but quantum mechanics really doesn't have anything to do with the idea that energy comes in packets, quanta, and that it's mechanical, because they don't think it's mechanical. And will be the basis for most inventions going forward. I cannot and should not be abandoned. It cannot and should not be abandoned. So I guess he's saying quantum shouldn't be abandoned. I don't know. I don't think there's anything. I don't think it has any realistic. I don't think Einstein's relativity, the bent space nonsense, all that crap is nonsense. There's no time dimension. Anything called time dilation is just a byproduct of the fact that you've given atoms velocity, and velocity retards their function. Velocity changes the thing that has velocity. And then all this quantum mechanic crap is all based on some sort of wacky wave theory that has nothing to do with how things really get through the universe and travel. They're not vibrations in ether. They don't spread in multiple directions. And they certainly don't spread in multiple directions and then figure out to go in one place and just erase all their multiple directions. They don't they don't diagram where they're going and then go there. They don't create a bunch of information and then destroy that information to end up in one location. None of that crap can happen. None of those events happen. It's a nonsense explanation. It's a simple universe. It gets simpler going down. And as I've pointed out, you can explain it all by just recognizing that there's 4 things happening. There's force, moving the speed of light. There's matter that moves when it absorbs force. There's 2 kinds of force, electron force and proton force. There's 2 kinds of matter, electrons and protons, and they have opposite charges. And they interact with the 2 forces reciprocally, oppositely. There. That's everything. You don't need any more than that to explain everything that's happening. Alright, so let's play some of this shit. No, just see if there's my new comments since I'm here. Oh, look at that, a new one. Okay, rainbow triangle double slit. Nothing gay going on here. So, what the fuck are you talking about? Oh, Jesus Christ. Idiots. Levon's affair. What the fuck could that mean? Nothing gay. So it's a girl doing the physics. Yeah, that is going to be kind of gay. That's obvious, right? So, yeah. So, gee, duh. What a surprise. Girl physics has rainbows in it. Yeah, no surprise. Unfortunately, they are a little bit too cliche. Alright, maybe we'll do some of this Susskind shit first. So I'll just play some random bits. No, that's not a very good random
in the laboratory. We see particles, we see gravity, we see all these things.
Yeah. So more talk. You never saw gravity. You just see the effect.
And they're there. And so what this provides us with is a highly precise mathematical situation where we can try out ideas. And one of the ideas that was most important...
So again, this mathematical crap where math doesn't tell you what you can't do. It doesn't tell you can't make infinite wells, and it doesn't tell you can't make infinite waves, and it doesn't tell you that these infinities are retarded.
In all of this was the consistency of having quantum mechanics and gravity in the same mathematical theory. And I think by virtue of string theory and its spin-offs, I think we know with certainty now that mathematically quantum mechanics and gravity can fit together sensibly and consistently.
Now, okay, we know they can when they can't make it happen, though. Isn't that just so ironic? We know that they can fit together, even though we can't make them fit together. I mean, it's just so funny. The only way they're going to fit together is when you realize that gravity is just a force, just like photons, just like magnetism. It's all the same shit. When you figure that out, then you'll have figured out what your mistake was. But as long as you think bent space and virtual photons are 2 different things, well, you're fucked.
Even Stephen.
You can change right? Yeah.
Yeah.
So one way to think
he
about
did stick to his guns. He did stick to his
He's a
guns.
stubborn guy, but he would change his mind.
So this is where he was saying, like, he was saying, do you really believe string theory, blah, blah, blah? And he's like, okay, yeah, I'm half interested and half disinterested. Yeah, half of me thinks it can work, half of me thinks it can't work. So that was kind of a wishy-washy particle-wave duality bullshit answer.
That your theory not allow it in principle. Or better yet, that the theory never allow an experiment, which was it. Quantum mechanics doesn't say a particle can't have a position and a velocity. It says nobody can ever detect both of them.
Yeah, okay.
So again, by detect, so again, something always claiming that because we don't have the technology to measure them, all right, and we don't, and we never will, okay, we're never going to have a half a quantum, we're never going to have some little bit that we can throw at a photon. There's nothing going to be found that's smaller than. So you're never going to be able to interact with them in any other way than some dramatic way. But this is just horseshit that, see, even that, they can't even just say it, honestly. There's no law. There's no Heisenberg law. There's no rule that says It's impossible to know, because if we know, then somehow the universe falls apart. There's no rule that says the universe falls apart if we know its position and its momentum. None whatsoever. It's just bullshit. It could be known, and nothing would blow up. Nothing. The universe wouldn't crumble. It's just nonsense. Ugh.
California travel tip number 31. Bring a selfie stick.
Crap.
I guess.
1, 2, 3, go! Faster, faster!
2 commercials.
Happy Friday!
Generally, different ways of gathering information may come to the conclusion. One way would say it was here, another way would say it was there, without any contradiction, because nobody can do both.
Is there any worry that this way of talking gives so much emphasis to observers that we're being a little bit anthropocentric or something like that? That we're putting agency back into physics?
That wagon has already left the stable. Well, that horse is.
Yeah, so some answer that is, we've already crossed the yes, we're being irrational line. So it doesn't matter. We can be as irrational as we want to now, because we've already crossed the irrational line where, you sort of have to explain with some sort of extraordinary evidence why you're making these extraordinary claims. And so they just say, well, we've gotten away with so many extraordinary claims with no evidence. Why would we bother now showing up with evidence for any of this crap?
Already
That
left
was
the
the big
stable
part,
by
yes.
about 1926.
But
That was quantum mechanics, right?
That's weird. But are you, we're allowed to get on slight tangents here. When it comes to quantum mechanics, are you a many worlds person? Are you agnostic about foundations of QM?
Yeah, I think agnostic is the word.
Agnosticism.
Just quote my old friend Richard Feynman. This subject is so confusing I can't even tell if there's a problem.
All right, so this subject is so confusing I can't even tell there's a problem. And they call this a great model they have. The greatest scientific theory in the history of mankind, and they can't even agree on a description of how it works. No, it's many dimensions. No, it's wacky-tons. No, it's pixies. No, it's angels. I mean, it's just horse shit is what it is. Just shit. Made up shit.
With information. So, using ideas from black holes, from Hawking, from Bekenstein, and so forth, I think Goft and I both came somewhat independently to the conclusion you, under no circumstances, could you ever put more information into a region of space than its area. Area measured in little Planck pixels. And once you say that, you begin to think, well, maybe there should be some theory in which the interior volume of a region should be described by degrees of freedom that live on a boundary.
Can you explain the degree of?
So beyond a boundary, so again, there's this nonsense. So he basically says in one breath that, you can't shove more information in than the smallest bit of the universe. The universe is made of bits. You can't store information in something smaller than a bit. So any volume of information that takes more bits than you can't have that much information. So you can't store on your hard drive 10 gigabytes if you only have 1 gigabyte of hard drive space. Duh. But then he says in the next breath, yeah, you can.
Freedom is.
Yeah, it's a bit of information. A bit of information. No. And I won't try to describe what bit is.
So that's good. 0 and 1.
0 and 1. Yeah.
One mechanical version of that.
The quantum mechanical version of 0 and 1. Right. That there should be, if it's absolutely impossible that under any circumstances you can ever contain more than an area's worth of information, again, perhaps that means that.
Yeah, right. And there is no information outside the context of knowing every other piece of information, because it's all in context. Where something came from only means something if you know the difference between Venus and Mars. If you don't know there's Mars and there's Venus, then why would it matter what direction it came from? It wouldn't be information anymore. So it can only be information if those two origins are different. If coming from Venus means something versus coming from Mars meaning something. And if everything else was the same in the universe, if there was no difference between Venus and Mars, and it was Venus and Venus, then it wouldn't make any difference. There wouldn't be any information. There wouldn't be any relevant history. The only way you can have a relevant history is you have to come from something different. You have to come from a place that's different, a history that's different. If you're coming from a history that's all the same, then it can't matter. Information becomes nothing. I mean, this is just so obtuse.
He related to the string theory, synthesis of string theory. Did wrote a similar paper and called it holography.
Antidissociation holography.
Right. So he was very familiar with my work and that was where first work. So the reason Juan did not mention it was not because Juan has trouble mentioning other people's work. Because he didn't know.
No, right. So you had, based on black holes, this speculation that somehow the information was encoded on the boundary of the black hole.
Yeah.
Well, Desena has an example of specific space-time anti-de Sitter space where everything that happens in that space-time is somehow encoded on a boundary with one lower dimension.
Oh no! In my work and in the Tufts, the black hole is just a starting point. The eventual conclusion is that a region of space, no matter what's in the black hole or no black hole, will be described by such a boundary theory.
So this bullshit about, something going through a black hole and then being Xeroxed and whether there's a copy and then the hologram nonsense. I mean, this is just such bullshit. Somebody said that in a comment somewhere. They brought up fucking holograms. And again, I already went over this subject, but I mean, we're deceived by the way we see the world because we see it through this stupid little pupil. And if we saw the world the way it really is, that is, if we didn't have the pupil and we just had a retina looking at the world, well, we'd see how unresolvable everything was because the light would be coming. We'd see the images being cast from all locations at once. And there'd be no way to resolve any image because we'd be seeing so many of the same images. Every object would have an image, across our whole retina. There would be that image everywhere on our retina. I mean, every item would have multiple images just filling the entire surface of our retina.
Right.
But we had absolutely no idea how to build that kind of theory, and it really was a speculation. I wouldn't say a wild speculation because I understood the reasons that we were pushed to it, but it did sound pretty out there.
Yeah, right. Like your crap doesn't sound out there. Amazing.
What's a bit? Well, a bit is a switch which is either on or off. A quantum bit, which is called a qubit, is a quantum mechanical version of that, but it has more. It's a richer thing than a single bit. It can be in a superposition of states, not up, not down, but up, plus down, and so forth. So quantum bit.
Right. So it can be in irrelevant states, indecisive states, wave particle states. What I don't know what. Yes, no, maybe. Oh yeah, that's really good for a computer. No, it's really bad for a computer.
It's a more complicated thing. Now, quantum bits, a collection of quantum bits, has enormous capacity for what I call complexity, much more so than the corresponding classical. So
this is all kind of horseshit. It has nothing to do with complexity. It has to do with shortcutting. So basically, the only way this qubit crap could ever work is basically their theory is that you really don't have to do the math anymore. So you don't have to do 2 plus 2 equals 4. You can just jump to 4. That kind of thing. You can just jump to answers and you don't actually have to do the process of adding anything or dividing or multiplying.
the amount of information that.
So this is all qubit crap.
But thinking about a phenomenon that the quantum computer and quantum communication community, it's called quantum teleportation. Quantum teleportation is a way of using entangled systems to send messages which are entirely secure and which seem to go from one place to another without passing through the space in between.
Right. That seem to do this magical thing. And again, and they'll describe and say, look, we've done it in the laboratory. We've successfully blah, blah, blah. And they haven't really done any of that. They have, they've barely gotten over the margin of error, so to speak, if they have done that even at all. And so they have a tiny glimmer of evidence, but that's it, just a glimmer of it, like there might be some hope. But I would argue that's only because of the errors in their own theory of how the experiment works, and there really is no glimmer. There's just wrong assumptions about how the experiment works. And again, most of these entanglement experiments involve detecting photons, their state based on their polarization, which, as I've already pointed out in the previous videos, polarization, it can be argued, polarizing filters do not merely sense a property of the light. They actually change the light that goes through the filter, which is which as a fact ruins their experiment.
I think about these days was ideas that were born out of computer science. The most important of which is called complexity theory, which turned out to have a direct application in theories of black holes. Okay.
Complexity in what sense? How does computer scientists think about complexity?
Yeah, right. Complexity theory and black holes. I mean, they're just more. Why are they combining these subjects even? It doesn't even make any sense. I mean, in principle, the black hole is a simple thing, not a complex thing.
The complexity, you can think of the complexity of a thing, or you can think of the complexity of a process. But of course, a thing is also a process. A thing is a process, the process of making it something simple.
Yeah, fair enough. How do you assemble something?
Yeah, the definition of computational complexity is the number of minimal simple steps that it takes to go from A to B. So if you're, let's talk about, I'll give you some examples of complexity.
Well, you need to go from A to Z and have some complex states in between, like going to B and C and D and E and F and G. So even that metaphor is the complexity of going from A to B is not complex.
My favorite was always, when I was young, I was interested in theorems. I don't prove theorems anymore, right? But it was interesting.
For someone else to do.
I was very curious about the fact that some theorems are hard and some theorems are easy. What's the difference? I mean, they're either true or they're false, but what's this hard or easy? What does it mean? My teacher, my high school teacher, told me the four-column map theorem is thought to be very, very hard. It's like, hard. It's either true or it's not true. How do you make sense out of this idea?
Yeah, so I couldn't quite tell what he was talking about, but a four-something Machiavellian or something.
Black hole physicists, this is the hottest item now. That's YK theory.
I mean, it helped to be as brilliant as it makes it guitar. Just
Yeah,
look
yeah,
at this
yeah.
and go, oh, that looks like a black hole.
Right. But yes, that's right. Think about it. It was a material science guy, a condensed matter physicist, and a quantum computer guy who found the opening, and I think it's a serious opening, for new ideas about black holes.
That is amazing. It's a wonderful synergy going on.
Interesting question. How long will it last?
Yeah, right. Wonderful synergy between computer science now and physics. Sorry. It's all just bullshit. So anyway. I mean, it just wasn't any interesting physics at all. It was all the very tangential to actual physical experiments. I mean, all the stuff that's just tiny shreds of evidence, if any at all. So, in other words, pathetic.
In our figure, we can replace the waves with the direction of motion. Now it turns out that the
Yeah,
electric
the
field of
photon.
light is perpendicular.
Yes, the photon. So this is just, incidental to it. So just create some geometry to explain geometry, right? I mean, you can always associate geometry with geometry. That's like Pythagorean kind of math. There's all kinds of associations between why the hypotenuse is where it is based on what the two sides are doing. And this is just doing the same thing. It's not explaining how the mechanism works. It's just showing you a way of relating the mechanism. So if I put a perpendicular line here and then I do a perpendicular line in a slower medium, I'm obviously going to change one variable somewhere. And once I've changed that variable, then I'm going to change the weighting, how the line is weighted, and now the angle's going to change based on how I've weighted the line. I mean, this doesn't explain what's causing it to bend.
The direction that light is traveling. And we can add that field direction to the diagram. And it's very important to remember that this field has a component both parallel to the surface of the glass and one that is perpendicular to the glass. And here is where Maxwell's equations come into play. Two copies of the equations are written here. One that covers when light is traveling in air, and one where it is traveling in glass. So here's the key point.
So it's the same equation. They're all just sitting there changing the constant. I mean, it's such mush.
The surface belongs to both the air region and the glass region. This means that at the surface, the equations on the top and the equations on the bottom have to apply. And with that little bit of calculus, you can find two important restrictions. The first is that the electric field parallel to the surface of the glass has to be the same in the air and the glass. And similarly, perpendicular to the surface, what has to be the same is the electric field times this epsilon, which is different for each material.
Right. And the epsilon is now just the permutivity argument. So again, they're just taking a constant, changing the constant, and saying, oh, what a surprise, it changes the angle. No, it's no surprise at all. Because that's what you've written the geometry to do. You're using the epsilon to change the intensity of one of those vectors. Shit. Duh.
On its molecular makeup. We can then manipulate these equations to see what the electric field in glass should look like. Because epsilon is bigger in glass than in air, that means that the perpendicular electric field in glass has to be smaller than it is in air. Now we remember that the direction the light travels is perpendicular to the electric field. So we can put in an arrow to show the direction light is traveling in the glass.
So we could just invert this change in the angle up here into what the change would mean going down here. So instead of a reflection that you're changing based on, like, say the air was thicker over here and you would have this change in the angle of this reflection, they've just turned it into a refraction by inverting the angle by whatever, 90 degrees. I mean, bullshit.
And finally, we can see what light does when it enters glass or water or any transparent medium. It bends. And the reason that it bends is because the epsilon in glass is bigger than in air.
So again, he's just saying the reflective index. So he didn't explain anything about how it happens. My argument would be that clearly the surface is what's causing it, and surfaces of transparent mediums have to have a certain kind of geometry to be able to transmit light in the first place. They obviously have to have a kind of purity, that is, the medium can't be full of dirt. And so what's happening on the surface is a reflection of the total medium, and the atoms don't, are all lined up with each other in a geometry. So if you have a positive in one location, the negatives can be closer, but the positives have to be further away. So you could make the argument that the atoms are not sitting side by side, that they're staggered. And so there's one atom up here, and then the next atom over here is down, and the atom over here is down, because they're kind of lining up like magnets have to line up. And there's a geometry. And so when you're hitting the surface, you're hitting that geometry. And where you hit on that geometry will dictate whether you get transmitted or reflected. And if you get transmitted, it'll be by the same angle because they're sharing the pressure. So the surface has the same pressure. And so it's always going to bend at the same angle because it's going to move the electron the same amount. And that's what's causing the effect. But anyway, it's the surface is where it happens. There has to be a model of the surface somewhere if you want to do any fairness to describing what refraction is. You have to describe what surfaces are. Otherwise, you're just talking shit, in my opinion. All right. Enough of a video. This computer is not underperforming. But anyway, it's getting the job done, so I shouldn't complain. Mostly getting the job done. Alright, so that's the old one. Okay, so nothing in the spam folder. Good. Alright. So yeah, click on it. It shouldn't take this long. Blah, 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 blah. Yeah, finally. Alright, so till the next time and such.